Yeah, thanks to Brian and to Maury for inviting me to talk to you today. Brian and I first met, I was sitting in a conference room with looking at about 500 open FOA proposals in 2012, and there were 2,000 reviews, and Brian showed up, fortunately, because there were 4 of us with the job of plowing through all that and trying to figure out where the $140 million we finally spent would go. It's been a real pleasure to work with Brian over the years. So I'm here really representing RASEI, where I'm a senior research associate, which means I'm available to help teams that have a CU participant with proposals to anywhere and with just developing their scientific ideas. You know, you see a lot when you do an open FOA, you see a lot in 3 years at ARPA-E. Let's see. And as I said, I spent 3.5 years at ARPA-E and worked on 2 different open FOAs, actually. So this is a pretty ambitious title. I mean, if you've got, you know, some way of powering wristwatches off of motion, you're not going to win an ARPA-E proposal, an ARPA-E Open FOA Award. The idea is to, how do you get the best shot? How do you take your idea and have the best shot possible at winning? And again, I have another disclaimer. The opinions in this presentation are based on my 3 years, but there's no guarantees that ARPA-E hasn't changed a little bit. It changes as the program directors come in and out by design. And I will say I'm going to be a little bit more free to speak than Brian, because I don't work at ARPA-E anymore in any sense. And I'm free to tell you that I think there will be an open FOA coming out in the next few months. So pay attention. Whenever you're writing a proposal to anybody, you're telling a story. And we technical people tend to forget that sometimes. It's about storytelling. That's what appeals to the human brain. So the question is, what kind of story do you need to tell? So you need to first, you need to understand the funder's story. They're going to Congress. They're going to the congressional staffers. They're going to the White House. They're telling their story, and they're trying to make sure that they get to keep doing what they keep doing. And they have a story that they tell again and again in ARPA-E. They tell it to program directors coming in, so they make sure they buy in. They're telling it to Congress. So the first step is to understand their story. A proposal is an effort to weave your story into their story so that they can picture you extending and improving the story they tell. So the first thing you have to look at is, what are the words the funding agency tells about itself when they're trying to sell itself? And a lot of scientists skip that stage. Okay, you tell it from your point of view. You got to tell it from their point of view. So I just went to their website and had a look at some of the things they highlight. And you can find out a lot about it by, well, all these things are there. Brian talked about most of them. You see, he's telling the ARPA-E story, and he touched on most of these points. There's a bunch of, how do you get the, it's the middle for the laser? Okay, well, you know, they tell about how they launched. They tell about how much they've invested, so they want to invest in you. That's good. They talk about how much private sector funding. So your story needs to tell them why it's plausible you're going to get private sector funding someday and build their story. They talk about how many startups they've launched. You need to tell them how many new companies. You need to tell them about that, or you're getting new company funding. But you can go back even further to look at the, you know, now mythical stories. They're true stories, but, you know, there are many stories you can tell about an agency, and they point to the Nobel Prize winning founder. So you know they want scientific and technical excellence. They've got a Nobel Prize winner behind them. So what is it that the story is? A heritage of scientific excellence. They aim boldly for big wins. A new startup venture is what they're after. You know, they themselves are a new startup venture, so they want boldness, right? They always are portraying themselves as different than the other DOE agencies, and they are. Launch new companies, and it sets its offspring free as toddlers. They're always telling Congress that we might give them an extra year, but basically they need to collect the money at the end of this. So don't propose something that looks like it needs their money forever. It won't happen. I'm not putting this up to talk about it again, but this is an iconic slide that I've never seen something about ARPA-E without showing it, about disruptive technologies that change the learning curve. So they're not interested in incremental technology. Here's my definitions of some of those words. I know people jumble up on them, and it's helpful if you use them right in your proposal, I think. So transformational energy technology transforms the way we do something, generate, transport, or consume significant amounts of energy. And there's an internal definition that is honored perhaps in the breach as much as in the actual way projects are. But you need to be able to make some compelling story that you're attacking one quad of energy use. And, you know, so a quad per year of U.S. energy, if you like other units, is 300 terawatt hours a year. You know, so that's 30 gigawatts of continuous power or 100 gigawatts of solar. So you get the scale. You better have something that can attack big scale. That's why the wristwatch idea won't fly. It's true, you may have a transformative energy technology idea, but it's not transformational. And disruptive technology ends some incumbent technology's dominance. You know, whale oil lamps, they were great for a long time, but, you know, when they found oil in Pennsylvania, that was the end of them. You know, tube electronics, they're relegated to niches. I mean, we still do use tube electronics, but they've become a niche market. Now it's a little harder. Replacing step 7 of some industrial process, I'd say that can be incremental or not. And you have to make the compelling case that it's going to change, say, by 30%. You can imagine that's disruptive, potentially. If you're going to change it by 2%, you know, probably somebody will have another idea for lowering the cost by 2%. So keep in mind what they're after and what these words mean, because it's always transformational and disruptive and transformational. Okay? Now, if your technology is high risk enough for ARPA-E, it probably wouldn't be funded by the other offices of DOE, especially energy efficiency and renewable energy, the fossil fuel. None of those things would take it, because nor would venture capital take it today, nor would industry do it today, because ARPA-E wants to make a big difference. Remember, that's part of their story. And then there needs to be, as we've just heard, a tech-to-market goal. In order to attract, you want to be saying that you will attract private or public funding at the project end due to some established commercial potential. That means at the end of your project, you have to be able to say, we're going to have enough, so someone's going to want to give us more money. You know, technologies either grow or die. You get $3 million from ARPA-E. You better get $5 million in the next stage. You better get 10 or 15 million in the one after that. And so every time you have to be preparing your story for the next things, the next increment of funding that will be larger than the one you already got. So your proposal has to support the idea that you are laying the groundwork to get much more money than ARPA-E gave you. If it works, will it matter, is what they always show. And there's a high tolerance for technical risk, obviously, if you want something that will be both disruptive and transformational. So this is definitely not the ARPA-E approach. Again, this is another slide from ARPA-E. It's aimed, you know, impact, we've already talked about that. It's aimed at the mission areas, has a large practical application. The transformational part is in number 2. Challenges what's possible, disrupts existing learning curves, leaps beyond. 3, you don't hear people talk about too much, but I think it's important. I think that most fields are pretty good at finding the innovations within their own field. We're a smart bunch, scientists. We spend our career working in semiconductor transistors. We probably can know what the next great semiconductor transistor is using silicon, right? But interdisciplinary work is more likely to create transformations than work inside one field. So the best way to make a winning ARPA-E proposal, I think, is to get together with your friends in other departments, buy a six-pack of beer, and get just a little bit drunk, not completely drunk, just a little tipsy, and start talking about, well, what could we do with, you know, a bioengineered worm and, you know, a spectrum-splitting solar filter, you know? Because an interdisciplinary idea will catch the eye of program directors and get through the pile of thousands of concept papers that come in. But the basic ethic is science in the service of technology. So it's okay to propose science. There's a lot of science and a lot of stuff that ARPA-E funds. But it's always in the service of a technology that is clearly in the proposer's mind. Out of the mainstream, you know, it doesn't have technical financial resources today. So that should be clear in the proposal. And this brings, the team brings skills from different disciplines. That's, you know, what I was talking about. You've got a good idea. It doesn't have to be outside a field. If you've got a great idea, fine. For a new transistor in silicon, go for it. But the bar will be a little bit higher. So I want to just give one example from that Open FOA 2012, just because it seems it's an old problem, and we funded a new solution. You know, at that time, it was clear that utility solar, which is more than half of what's, utility scale solar is more than half of what's deployed, was about 3/4, now I think it's up to 80% of new installations track the sun through the sky, east to west. And they use a lot of expensive and heavy metal and gears, and the technology would have been extremely well understood in the 1820s. You know, so there was some room for some change. There's extra energy to be gathered over at the edges of that red curve, right? But you got to keep it really cheap. So there's those gears that would have been well understood early in the Industrial Revolution. So what this team did, it was Other Lab spun off a company called Sunfolding. Other Lab had a history of spinning off companies. That helped. And you can see that there's a compressed air driven bellows. This is not actually what they're doing exactly because I don't want to show that. But the idea is you can get an air-driven tracker that's mass-produced for pennies, basically the same way you produce a soda bottle. So what's transformational there, the promise in the proposal was, we're going to do it a completely different way and get rid of a lot of metal. We're going to have little tubes carrying compressed air into the field instead of heavy torque tubes that have to turn a whole line of trackers. Okay, transformational. We don't know yet whether it's disruptive. They've gotten their Series A. I think they got their Series B. I don't remember. And they're well on their way with demonstration projects. So why would you go through all this stuff? I mean, scientists...
It's probably worth noting that their original application was different than what they're commercializing.
Somewhat. Yeah, I mean, the exact shapes of the things and stuff, it was pretty early when they did it. It's also worth noting that when I had talked to the reviewers and talked to the people in EERE and talked to people in the field, everyone said it couldn't work. And everyone, that's a mark of a good ARPA-E proposal, by the way. Oh, there's always one reviewer who hates it. You know, you get 6 reviews in it by the time it's funded, and I don't think I've ever seen anything that got funded that doesn't have someone that doesn't like it because it just doesn't look possible to them. And they'd been rejected many times at EERE before it was funded. Anyway, why would you go through this process? Because they give big awards. You know, the average award is more than $1 million per year, really, or about $1 million a year. Yeah, I put $1 million plus or minus 0.3. And you get to keep it for 2 or 3 years. So you can get some work done and you can have your dreams come true. At least have the chance of making your dreams come true with a lot of money. So the rumors, I call them credible and persistent. I mean, it started with the acting director of ARPA-E announcing at the last summit that there would be an Open FOA in 2018. There is, I can keep track of money pretty well, and they definitely have at least $100 million in the bank saved up for this. And so why would they not spend it on this? So independent of whether they get refunded, in December, I think there'll probably be one. And the rest I probably shouldn't talk about for fear of incriminating people who work inside the organization, but I think everyone inside the organization thinks it's pretty likely, despite the politics of Washington today. So I think that it'll be issued before February, but I don't know. So here's how it goes. The FOA will be announced. You have 6 weeks, as I said, to submit the 4-page concept paper. Your actions here are in red. What goes on behind the scenes is just for you to understand. The concept papers will get 3 to 6 reviews, internal and external, so be read by a lot of people. And I'll point this out later. It's very important to notice there aren't that many specialists on the ARPA-E review list for every one of thousands of concept papers that are received. So it will be read by specialists and non-specialists alike. Okay? Each reviewer is reading 10 to 50 concept papers. That's a lot. It's a pretty big burden. And they're not getting paid, and so they're a little fed up. At the next stage, they get paid. So don't expect them to read past your title and the first figure in the first paragraph. Okay? That won't be 100% of cases. Then there's a decision by a PD or a PD panel, ratified by management, basically, and the PD's reading a couple hundred concept papers in the new system. In the old system, it was more. Then you'll have 6 weeks, if you're accepted, to submit the 20-page full app. And then there'll be 3 to 5 more reviews, and by the PD, so the PD is going to be reading all of them in some area. And then there'll be a panel, and they'll talk about them. And so that proposal really has to stand up to a lot of scrutiny by a lot of people from a lot of different fields. And again, it won't be only experts, and it won't be only people from your field. And then you'll get some feedback, and you'll have 72 hours to respond. So when they tell you you're going to get the rebuttal letter soon, cancel your fishing trip. And then the hard work starts at that point if you win. Okay. So if it works, will it matter? So the way I interpret this is it plausible that the technology will work? Your proposal at best prove that, right? Is it plausible that the technology can work? What does that mean? Is it consistent with physical law and known facts? Right? It seems a low bar, but we saw a lot of things that violated thermodynamics and were clearly completely crazy. And a few of the ones that were clearly completely crazy, you'd give off to a fellow and say, this might be something here, I don't have time. Can you just tell me one way this is not completely crazy? And then it got back in the pile that way. So, it's okay, but you want to at least establish that. Are there any preliminary experiments or theory to suggest the idea could work? Really useful to have a little preliminary data. Too much? No. If you show the full data set, you'll never get funded. We already did it all. It's proven already. Why would ARPA-E give you money? Right? So you want to have some preliminary experiments and theory. Is the time and budget you've asked for? People always are asking me, how big should I write it? Well, you want to be able to eliminate the toughest risks. You're not going all the way to a company. You're not going to be putting something on the shelves at Target at the end of 3 years. So you have to be able to establish in your proposal, talk about the highest risks. We call it the long pole in the tent. I think Google X talks about the pedestal problem. I mean, they're trying to teach monkeys to direct traffic in cities. And of course, the team wants to work first on the pedestal that the monkey will stand on, right? That's not what ARPA-E wants to see. They want you to work on training the monkey. Okay, so we're going to get the highest risks out. We got enough money, and we can prototype something that says great technology can soon emerge. Okay. Again, if it works, will it matter? Is it disruptive? Does it attack one quad? And then as far as tech to market, for the Open FOA, the question is, could this team, so the burden's a little higher here, could this team identify and initiate a plausible path to market? For the focused FOAs, the program director has already done that legwork for you. They've already said there could be some market there. In the Open FOA, you read them and you just say, geez, is there a market there? I never heard it. It helps if if there's a half a page that explains why this thing could sell someday. This is what I talked about before. Write someone for everybody, because you can see the hypothetical reviewers down there. We fund only those proposals we can understand. It's a cartoon, but it's very serious, right? If you have a lot of people reading this that don't understand it, and on the concept paper phase, you can assume that probably 6 out of 7 of the people that read it won't be from your field. If you're lucky, you'll get 1. If you're really lucky, you'll get 2. So write it for them. Yeah, they've got their high school degrees, they've got their college degrees, they got their PhD in something, or their master's, or a lot of practical work experience in something, but probably not in what you would like them to know. All right, so you should anticipate it. If it doesn't come along, oh well, you've just developed a great energy idea. Have some fun over the next few months. Be interdisciplinary if you can, get a preliminary result, and define clearly what the critical long pole challenge is that you would have to prove to make someone actually believe you. Doesn't mean it can be done, getting the monkeys to direct traffic. But that's the big challenge, and that's what you're going to work on. And then the question came earlier, how much of this tech-to-market stuff do I have to do before I put it in? Well, you don't have to do a lot, but I think you will position yourself much better if you've done something. It's not that hard to do a back-of-the-envelope calculation. I've got this much silver in my product, and I've got this much polyethylene, and so there's certain irreducible costs. And then just claim, you'll have 10% engineer, 10% manufacturing costs, take your fundamental materials costs and just add it up. We're talking about getting right within factor of 2 at that point. And that makes your proposal look a lot more compelling to people. Why? It's not because they believe your estimate. They know you're probably, lowballing everything. It's because it shows you have enough interest in the problem of cost to make the calculation. So you're more likely to do tech to market after I fund you, right? If you didn't have enough interest to put a paragraph in that says that tracker could cost, this many cents per kilowatt hour, and compare that to that many cents for the existing ones, then I'm not sure I believe that it matters whether you succeed technically, because you didn't put the effort into that. And it can also help to have someone at a few % funding who's capable of making those estimates better and saying, we expect in our first milestones to really improve on these crude back-of-the-envelope calculations, right? And then there's, write the concept paper showing how your story fits the ARPA-E story, plausibility and high eventual impact. Write the title, opening paragraphs, and summary figure 1 to capture the reviewer's attention. Now, here's a couple examples, as Brian actually gave me this slide on this that I've adapted here. You want to summarize the whole pitch, especially in the concept paper, in figure 1, all the way from context to transformational technology. This is the one that Brian talked about earlier on the left. They showed it's for windmills. Okay, it's obvious to you. Most proposals leave it out. Right? And so that your reviewer, who's bored and on their 45th proposal, immediately knows they're reading a proposal about windmills. That's good. It's got these structures in it. And then it's got some fancy scientific words maybe I don't understand about tension fabric, but they're going to do something. You already know everything about that proposal, right? And the left one's a little more elaborate. I think it's a little more over the top. I wouldn't necessarily do it, but many proposals do it successfully and carries the whole details of their monitoring scheme, in this case for methane. So that figure 1's really important. Don't do it yourself. Trust a professional. My rule of thumb is overworked reviewers are 90% decided by the end of the intro and figure 1. So spend some time on the introductory paragraph or 2 and figure 1. If you can get them thinking that it's probably a pretty good proposal, they'll read all the details, and if your equations are upside down, they'll turn the paper over or something, turn their laptop over. You know, but you got to grab them early. Title, first paragraph, they're reading a lot of them, especially at the concept paper stage. As I said, they don't get paid till the full app stage, so they're also a little grouchy. So you got to tell them, obviously, what will be done and where you will be at the project's end. And that doesn't have to be the design of the pedestal, right? Because they know, I know when I read that proposal, that they'll manage to design a pedestal with rails on it that monkeys can't climb over or fall off, right? So you need a technical endpoint that will bring in the next funder. And you can explain exactly how that'll work. When we've done this and this and this, we know them and them and them will fund it, right? The riskier the science you're doing, the more important is the milestone chart. But there needs to be a good milestone chart, probably. Show early milestones for the highest risk advances. If you defer it till the third year, I don't think you're serious. If you defer starting to train monkeys until the third year, I just don't think you're serious. You know, if you won't work on the high-risk stuff, you're wasting my money. I only have the clout to give away $30 or $40 million, maybe, you know, inside ARPA-E. You know, if you think you're boxing yourself in later, don't worry too much. They'll box you in at that first meeting regardless. After you get the award, they're going to come in and say, I liked your technology, if you're lucky to get it without a good milestone chart, but we need an early milestone to make sure that, you know, you can get monkeys to sit still well enough to learn, you know. And then your final milestones in the third year should address system integration. They should address how you're thinking about getting money. That you're going to, in the end of the proposal, you're going to be thinking about getting money, because that's where you're trying to match. Include some T2M milestones, you know, progressively better. As you know, the first one is the back of the envelope for the proposal. The next one's with the spreadsheet early on. And as your technology changes, now you have more silver but less platinum. So maybe that lowers your costs. You got to be recalculating that at regular intervals, you know. And prioritize the search for good niche markets that can open high-impact markets. Energy is a tough business. And you don't just jump into competing with, you know, an oil well that's being drilled with, you know, 150-year-old technology that's developed incrementally and gradually to some spectacular level today. You got to have something you can sell to someone that they need, well, so that you have a scaled-up facility, a scaled-up manufacturing facility. So niche markets are important, and that's the exploration that you need to do, as long as you never lose sight of the fact that you're going for a quad of energy eventually. Okay. All right, so this next section's a little odd. Whoop. Oh, what happened to this? Yeah, picture's worth 1,000. All right. So I assume we have people from universities, some academics in here, probably a lot of you. So I want to tell you what some of the common perceptions are so that you can build your proposal to dispel them, those concerns. And I'm going to do the same for industry and national lab in my next 2 slides. So we're not singling you out. These things aren't necessarily true. It may hurt to see them written down, but there's a lot of people at ARPA-E that believe these things, and some of it's based on experience. Some of it's actually true. So 2 things that I just pulled out. I probably could have found more. First, you'll propose based on nothing. You're an academic, you like to think. Second, you're mainly interested in making papers in a PhD thesis. Obviously not inside the story. And you are interested in graduating PhDs. So maybe you shouldn't apply to ARPA-E. But what do you do in your proposal and in rearranging the way you think about your working life so that you can be successful in ARPA-E? You know, as I said before, include preliminary data, or at least have some serious calculations behind it. So you're not proposing based on almost nothing, right? And then I probably should have added in, well, and then the next one, mainly interested in making papers and PhD theses. So you really have to think about, you're making a pitch. If you're an academic, you're pitching a program director on your genuine interest in moving to market. at the end of reading it, they should think that about you, that if this really hits, you're going there. So have a strategy for commercialization that goes beyond, our technology office will license this, okay? Because when the PI, when the principal investigator on a proposal doesn't commit to commercialization, it doesn't happen. You need some technological heavyweights committing at least some of their time to doing it. If not you, then you got to have a substitute, and they've got to feel it from you. This is not the same problem faced by a startup, of course. This is the particular problems for academics. It's helpful to have strategic industry participation, even if their only role is making a measurement or doing some fabrication for you, someone who might possibly take it out into market. Because I know that if they're engaged early and they've got one person even inside that company who knows what you're doing intimately, it's more likely that the big company will invest or the small company will make it into their product. A rough cost estimate, as I said, track record. It's helpful if someone on your team who's worked in industry in some way to dispel this. And I know this is awful for you, but if you write a 2-year proposal or a 2.5-year proposal, it says you're serious, that you're not just interested in getting PhD students out. The 3-year proposal is just the right amount of time for someone to write a PhD, right? So we all think, oh, I have to write 3 years. Well, there's no better way to subliminally reach your program director than to propose something shorter. It's hard to manage. There, now I'm unpopular with a bunch of the people. Now I'll get unpopular with the next third of the people here. If you're in industry, okay, you usually propose incremental change to the present technologies you have. Why? You don't want to retool everything. It's a big hassle if you're a small company. If you're a big company, you've already invested in a huge amount of money in something that's making you a lot of money, hopefully, and you're probably not going to change it much. So you really have to explain really clearly how this idea is disruptive and outside the box for your company. Because I don't want to fund the same thing you're doing already. The perception is, yeah, if any professor comes to you and says, will you work on this with me? You'll say yes, because it'll help you balance your books, especially if you're a startup. That's not so true for big companies. So assign someone strong to the project, not the person you're having, you can't figure out what to do with them because they're not very good. Make it clear that they're good and somehow convince the PD of a genuine interest. Another perception is that maybe small startups lack the equipment to get the job done. So in that case, bring in a partner from a university who's got all the equipment you need in the national lab and highlight that. Own it. We are a small company and we don't do, this kind of, we don't have a focused ion beam milling, but we have a strong relationship and have already collaborated with, this party that has focused ion beam milling or something expensive. And show that you have past relationships and you know how to work with, with service shops who will do characterization and fab for you. I mean, so much of what's done in startups is not done in-house today, but bring it out clearly. So maybe your academic reviewers will get it. Like, we don't have to do everything in-house. We can pay someone $20,000 and they'll make new parts for us or even new nano somethings for us. And then the last thing, if you're in a big company, they let their researchers propose, but aren't really interested in commercializing new ideas. So they've got an R&D shop, but in the end, it's just hopeless. The CEO's not going to invest in it anyway. So describe within that big company, what is the realistic path to really launching a new venture? Do you spin things out? How does it get there? So knowing what the stereotypes against you are is important. National labs prefer to study a problem forever to lock in long-term funding. I see Brian nodding. Now, I worked for 25 years at NREL. I love national labs. They have capabilities like no others. I've seen in my projects they can bring it. I've also seen national labs that behave very badly. And from the first day, they were talking about how do we get a 4th year out of this? You funded us for 3 years. What are the conditions for getting a 4th year? And a 5th year. What? You won't give us a 6th year? I mean, so you're going to have to fight that. somehow your proposal is going to have to establish your genuine interest, your track record of doing something outside your normal program sponsors. It's not enough for ARPA-E to think that maybe at the end of this you can transfer this into EERE and work on it till you retire. Okay. Describe how the technology will escape your labs. And again, don't just say we license technology. That's not a pathway. And again, shorter proposals speak urgency louder than anything you can write in the proposal. And then the other perception is that ultra-high overhead will waste the PD's investment, right? Again, each PD's informally can only get so much money out of the system, right? If they get more for you, they probably can get less somewhere else. So blend in some lower-cost university partners, get the grad students do the labor, make it clear that the labor costs are not all going to be associated with the lab overhead. Get industry to put in cost share that exceeds the legal minimum. That's good. There is some legal minimum depending on the stage of your business, and I don't know the details. You can always find it by looking up any FOA to find out what the cost share requirements are. They've changed over the years, so I'm not quite sure what they are right now. But it's look up any recently issued FOA, you can find the cost share requirements. And then, you know, the bright side of National Labs is we had incredible facilities and incredible equipment. Bring it out clearly to make sure that people understand the unique capabilities you have, so there's no choice. Leave the program director no choice. There's no one else who could do this work because we need this kind of foundry. And if your lab work is highly automated, bring that out too if you're doing combinatorial work so that they think they can get a lot more work for the buck. That's all. So you're trying to get around these perceptions, and I'm sure there's other ones. But all right, my last couple slides are just, I had the opportunity, I was consulting, and I had the opportunity to look at some concept papers that failed and some concept papers that won, and just to give a postmortem on why. So without telling you anything about the technology, I can show you this was a real concept paper, you know, that I wasn't working at ARPA-E because that I wouldn't be able to disclose anything about. And, you know, in this case, the impact was clear. You could just read it there. They claim 0.2 quads per year of total energy saved. If it was fully adopted by the marketplace, which everybody knows it won't be, right? So it just wasn't big enough. And then there were some questions about whether even the existing stuff could possibly retrofit. You know, there was an industrial partner mentioned, like they'd gotten the memo, have some industry on your proposal. But they were assigned no work, and there was no bio. Okay, so do I believe that? Do I really think that industrial, it's worse than not have, better to not have an industrial partner than to put in a symbolic ghost-like industrial partner that doesn't really exist. And anyone who reads it knows you're not serious, and they're not serious, okay? So the reader will suspect this is basic work without a path to market. And then, again, same problem, proposal didn't punch the main ideas through, you know, early. You couldn't, it's nice to be able to say this is the state of the art and we're doing something much better, bigger. What was the single high-risk impact innovation? It sounded like 3 technical miracles were needed. As Brian alluded, like, I don't mind 2, I don't like 3, you know. 1 is, if it's big enough, that's good, you know. 2 might be the sweet spot on technical miracles. You probably have to have at least a half a technical miracle or you're not going to get funded. So here's another one. This one had a goal of chemicals production, you know, something solar-ish, I think. But the amount of carbon that you can put into any chemical turns out to be just tiny compared with the scale of our CO2 problem. Burning fossil fuels is a huge business, and you have to promise you're going to do something that's significant. ARPA-E has an internal thing. This is, again, it might have changed by now. There's mostly different program directors than when I was there. But I think anyone who looks at this seriously realizes there are no specialty chemical products and few chemical products that are energy significant, except maybe cement, aluminum, steel, maybe glass. There's a few. But unless you're targeting one of those, if you're targeting pharmaceuticals, like, no, We may take a lot of opioids, but not at that scale. And there was no contrary information and proposal. So not saying you can't do it, but you know that that prejudice exists against your proposal and address it head on. You know, as an entry market, chemical production's great. You know, you got a new way of making algae go 10 times better than what we got today, and you're going to get in by making pharmaceuticals, and then you're going to revolutionize fuel. Go for it. You know. Nothing wrong with chemical niche markets. Again, same problem. Industry partners mentioned, not participants, and their connection was vague. Here's one that was encouraged. So some are encouraged. You know, the idea looked innovative and possible. It had some rough calculations of cost. It leveraged the incumbent technology. So if the incumbent technology improved, or one of the incumbents, then this technology would improve too, because it was built on it. That's nice. Like you're just always better than the incumbent in any cost reductions. Because a lot of proposals assume all the competition will be stagnant. And by the end of 5 years, I know all those technologies will move forward. So it's helpful. You know, they described the technology advances in a related device that made the time right. Like, why is the time right? I think that's one of the Heilmeyer questions. Why is this the time for this to go forward? People may have tried it 15 years ago. That's okay. Now we have a lot better technologies in a lot of areas. It stayed away from detail in the concept paper, right? Except for a short task. This concept paper doesn't have to have all these milestones. Be big thinking, be expansive, but show you're serious about the deep stuff that will come in the full proposal. You know, they did back-of-the-envelope cost estimates. They partnered with an industrial entity and had a clear role for them, I think, identified a niche market. And the summary was really clear about the opportunity and vision, so even the board referee would have gotten that far. So, to summarize my talk, you know, you got to understand the funder's story, and ARPA-E has a very unique one, and they're very transparent. It's right there on the website. It's right in Brian's talk. It's right in any talk anybody gives. Disruptive technology change, novel applications of advanced science and engineering. I shouldn't just have said science there. ARPA-E is interested in engineering. No new scientific principles needed. Compressed air solar trackers were not new science. There was, you know, they had to get those bellows just right. It was a really interesting technology challenge. But they had an idea. They said, wow, why all that metal? Why all those gears? You know? And we took a bet on them. You want to make sure you're convincing that your technology has a life after ARPA-E, because that's what they want to tell Congress at the end of your project. We funded another startup that's launched, and they just got $10 million in VC funds, right? And that there's a chance of market success, where they'll actually change the energy picture. So help ARPA-E in your proposal see you extending and improving their story. Okay. So here's the plug for me. I work for RASEI part-time, quite part-time, but I am free to people who have CU people on their teams that are even thinking about proposing. We can sit and we can brainstorm. You can refine your concept for ARPA-E. We can, you know, brainstorming, believe it or not, I can even help in fields where I haven't necessarily worked. You see a lot of stuff in 3.5 years at ARPA-E and working on 2 open FOAs. I've seen stuff from almost every field of energy. And the interdisciplinary stuff hopefully have some of those sparks with you. Help you refine your concept, help explain to you how you're going to do that back of the envelope calculation. You know, you're still going to do it. I'm not going to do it for you, but inspire you and guide you a little, help you build out your team. I know people who, from all my teams and others I've met in a long career, that have the expertise you probably need. And finally, I can look over your concept papers, how closely, you know, if I got a ton of full proposals, I don't know, but concept papers, I can give you that quick impression. And so contact me before a FOA issues is my advice. I'll work with you, and if don't have any connection at all to CU, I will say I have a private consulting business. There's the email for that, so there's the personal pitch. Thanks.
Thank you, Howard. Do we have any questions for Howard? Just a couple quick ones. And we're going to take a break. And I'm going to make you do jumping jacks when you come back. No, I won't. But because I see you fidgeting. Any questions for Howard at this stage? Here's one in the back.
When you get the reviews back and you have 3 days or 2 days to reply to the reviews, how important is that? Because anyway, let me just finish that part, just like that. How important is that you reply to that reviewer's review?
Extremely important. And I just worked with the team here, and I was able to help tease out for them which of these things came from the program director and which came from the reviewers. You get a set of reviews, you get a couple pages of comments. It might be hard for you to tell, but I have every program director at that point has some lingering questions that would prevent them from funding you. And they sort of bury them in a way you may not be able to tell whether it came from a reviewer or whether it came from the program director. You better answer those questions or you're not being funded, period. So it's incredibly important. Answering every single point on it, if it came from a reviewer and it's a stupid question, no. They only give you 2 pages. You can't answer everything. So it's an art form. It's a hard task.
Okay, but it's basically, I mean at that stage, the PD hasn't still made any decisions, and he's just looking for the last couple of things to help him.
That's correct. Get her or him over the finish line, right? Okay. They say, well, the one thing that's bugging me is meta-organic frameworks are always going to be way too expensive to use for anything. And they'll put that question in, and you better hit that question because they may, on how that particular component of your system is actually going to be made cheap enough to do the job, to reach commercialization,
So please thank Howard